Kia ora team and welcome to the online tutorial. Today we're going to be looking again at a 2017 Level 1 NCEA Mechanics exam, this time question 2, A through C. Let's get to it. So for question 2, and you'll have to ignore my attempts at filling in the pictures, they are pretty paru, but that's alright. A lightweight waka ama, or outrigger or dual hull canoe, has a mass of 9.9 kilograms. Our first question A asks us, what is the difference between mass and weight? And then, using our waka ama as an example, include a calculation for its weight. So, let's get to it. If you're in my class, you probably know because I harp on at you all the time. Mass does not equal weight. Mass is the amount of matter that makes up an object, okay, and will be constant no matter where you are, because changing a planet, etc. doesn't change what you're made of, and is measured in kilograms, whereas weight is a force due to gravity acting on the mass of an object. Because it's a force, we measure it in newtons. Now let's calculate that force, but quickly I'm just going to fill in our equations here. Now bear with me for a moment because I've just forgot to put this across from our previous question. A little adjustment and boom, Bob's your uncle. Cool, that's better. Now I've got my equations. So we're going to look at our equation for force because we know that weight is a force and it's actually asked us to calculate that because we've already done the first part, which is describe the difference. Okay, so we look here and we can see that F net equals MA. F net equals our mass times acceleration. Now for us, we're going to be using the acceleration due to gravity because we're calculating weight. And at level 1, that's 10 meters a second squared. Now they've actually provided us with the mass up here, 9.9 kilograms. Okay, so we're just going to plug and chug, put that information in and do our equation. That equals our mass, 9.90, okay, times our acceleration, 10, and we're going to get 99 newtons. Let's move on to B. Looking here, calculate the pressure exerted by the waka ama and both hulls on the water. Okay, remember that a waka ama is a dual hull or outrigger canoe. And your answer should include an area calculation, assuming the waka ama hulls are rectangular, even though they're not in real life, but we're going to make it easy and pretend they are. And calculate the measurement that would be in contact with the water. Okay, and they've given us some numbers up here to do that. When we're doing mechanics, we like to write down our equations. That way it makes it really easy for us to make a calculation. Okay, so we're going to look for pressure. And it's not that one, that's power. Okay, we look for P equals F over A, that's pressure. So we say pressure equals the force. So we're going to have to calculate our weight force like we have in the previous question. Okay, and divide it by the area. So we know from the previous question that the weight force is 99 newtons. So we've got the force, but we don't have the area, so we're going to have to calculate this. Okay, using the information provided up here. So there are two hulls, so we're going to do two area calculations, add them together, and then divide this force by that combined area. We're going to write down the equation, area of a square equals base times height. So let's get that in. Hull 1, square or area, equals 6.55 times 0.40, which will give us 2.64 meters squared. Let's do hull 2. So hull 2 area is a little bit smaller. Our base is 4 meters or 4.00 meters times 0.15. Okay, which for us is going to equal 0.6 meters squared. Oh, I've made a mistake here actually. My calculation for this one was incorrect. That's actually 0.62 meters squared. I don't know where I got that 4 from. Anyway, let's ignore that. And let's go on to our combined area. So area 1 plus 2 equals our 2.62 plus 0.6, and we're going to get 3.22 meters squared. So now we have both a force as calculated previously and an area as just calculated now. P equals our force, 99, over our area, 3.22, okay? And it comes out to 30.7. Now, there are a number of units you can use for this, typically pascals, but I like to use the units provided, so we dealt in force, okay, so newtons over an area, meters squared, okay? But you can use Pascal or PA if you really want, up to you. Just going to quickly action off this area, so C has a bit more clear working space. Cool, let's get into C. C says, or asks us, the Waka armour sinks further into the water when a 67 kilogram paddler sits in it, okay? So previously, when you just put it on and it's 9.9 kilograms, it doesn't sink in that much, and then a dude comes along, or a lady comes along with a mass of 67 kilograms, sits in it, and it sinks a bit more into the water, which makes sense, right? Explain why the Waka armour sinks further into water when the paddler sits in it. Use calculations. Now, we know this is a pressure question. The area of the boat hasn't changed, but the weight force combined of the person in the boat and the boat has changed. First of all, pressure equals force over area, okay? We're going to state that area remains the same. Okay, because the boat has not changed, all right? But the combined weight force has changed. And it has actually increased. Okay. So let's calculate the pressure of the boat and the pressure of the boat plus person in it, and think about how that's going to change. Pressure of just the boat, okay, as calculated above, is 30.7 newtons per meter squared of pressure exerted on the water. Okay, let's do the pressure of the boat plus the rider, for lack of a better word. All right, now that's going to equal our force over area. Now our area remains the same. Okay, this is the same, but our force has changed, so we're going to have to calculate that. So our F net is going to be mass times acceleration. Again, acceleration being due to gravity. But this time we've got two masses, so it's going to equal the mass of the boat from before, 9.9, right, plus the mass of the rider, 67 kilograms, okay, times 10. And we're going to get a new force of 769 newtons, okay, which is quite a bit more than before, okay, 99. So we're going to use this number here in our new calculation, right, and we're going to say that it equals 769 newtons over the same area we calculated, which is 3.22, and we get 238.8 Newton per meter squared, okay, which is quite obviously a lot larger than 30.7. So we're going to say a few things, and again, I'm not going to write them out because I have very limited space, but you've got plenty of space. Okay, how much our boat sinks into the water, if you imagine it sitting on top, okay, actually depends on the pressure exerted on the water. So the greater the pressure, right, the more it sinks into the water. The lighter Waka armour has less force, okay, and therefore less force applied over the same area is going to be a smaller pressure exerted, as we've shown here with our 30.7 newtons per meter squared. In our example with our boat plus the person on top, we've calculated the increased force, which would result in an increased pressure of 238.8 newtons per meter squared, meaning that our boat plus rider is going to sink much more into the water because it's exerting a much larger pressure. So our heavier example, or our boat with a rider having a much greater weight force over the same area, is going to exert a greater pressure and they're going to sink deeper into the water. Hope that helps. And again, you would write that out normally in sentences or paragraphs. I don't have the space to do. Let's look at what we've covered so far. For A, we talked about the difference between mass and weight, how they're not the same, how mass is the amount of matter that makes something up, and how weight is a force due to gravity on the mass of an object, and we then calculated that for our Waka armour. All right. We then calculated with the area provided, or the details provided, the area that the waka armour would interact on the water, and use that to calculate pressure for our waka armour, as we can see here. Okay. We then discussed why, when an individual hops on top of our boat, it sinks further into the water. When we have the same area but a greater weight force applied, we get a better pressure, and the more pressure exerted, the more a boat sinks into the water. Hopefully this has been helpful, team. Hopefully this helps you to get out there and get into some more physics or mechanics. Have a good one.